nickel by means of the Mars process. First method, you have to nickel is mostly isolated from the nickel blend. That will be roasting method. First, we have to roast the nickel blend. Then nickel oxide is obtained. That nickel oxide is again we are using of the reduction process. That means in the presence of water gas, that is carbon monoxide and hydrogen. Then you are getting of the nickel. That obtained nickel is the having of so many number of impurities, make it to fine powder, and that is treated with the carbon monoxide. You are getting of nickel carbonyl. That nickel carbonyl undergoes the metallic, that means you are decomposes nickel carbonate. That nickel carbonyl formation of the granules of the nickel. So by this process you are getting of the 99% of the nickel. So after the getting of the nickel granules, you are purified with the help of the electrolysis method. By this, almost all 99.99% of the pure nickel is obtained by means of the electrolysis. That nickel is deposited cathode. So that the electrolysis is carried out at 30 degrees centigrade, and electrolyte is nickel aluminum sulfate is used. So this nickel is mostly, the nickel is used as a making of the alloys. Different alloys I already told that we are having of German silver, nichrome, platinite, monal metal, chrome nickel. That means it is used as a coins, making of the coins. And where the uses of the nickel means, first that is a making of the alloys is a one use. Okay, and also mainly important, this nickel finely powder of the nickel is used as a good catalyst. So many reactions the catalyst is used this one, and also it is used as a mainly important the hydrogenation of the oil. Good catalyst as hydrogenation of oils. And also nickel is used as the coat metal, that is it prevents the rusting. When you are it is treated with the iron, it is the alloy will be treated like this. We are getting off. So by that nickel will be extracted. Next we are going to the extraction of the uranium. Now we are discussing about the extraction of the uranium. So here important minerals are number one, we are having of the pitch blende. This is EPOH. Second is carnotite. This is the second one. This is the formula is K2O, CO3, and K2O5, uranium pentoxide, and n number of water molecules. This is the carnotite mineral, which is also important for the extraction of the uranium. And third is actinides. Actinides. This is the calcium oxide, uranium trioxide, phosphorus pentoxide, and NH2. Okay, here are the important three minerals. By the three important minerals, uranium is extracted, and mainly here uranium is extracted from the pitch blende. Pitch blende is an important one. From the pitch blende, we are extracting the metal. So, what are the process extraction will be takes place? We are having now so many number of process. Here, I simplify that extraction of the uranium. The first process is concentration of the ore. Already you know that the how to ores are extracted means we are having of three steps: concentration and also extraction of crude metal. Next is the purification. Like here also the concentration of ore. Here the pitch blende, first pitch blende is crushed into fine powder, and That particular fine powder is crushed into fine powder, and magnetic separation, and also fourth flotation method. Magnetic separation and fourth flotation method, you can separate it. That means you are concentrated the ore. Okay, the ore is concentrated with the help of the magnetic separation and also using the froth flotation, that is sulfide ores will be eliminated out. Sulfide impurities will be eliminated by means of the froth flotation. Okay. So magnetic substance is magnetic will that will be there. This is our first method. Next is the roasting method. That means the ore is roasted, but after the getting of the concentrated ore, we are roasting step. Roasting means we are having of the using of pitch blend U3O8. It is roasted means in presence of oxygen. You are getting of the 2O3 and the remaining other whatever the impurities which are present as a carbon dioxide and sulfur dioxide is removed from this process by means of the roasting method. Okay. So during the roasting process, what happens is the volatile substance like that arsenic and antimony. Arsenic and antimony during the roasting process it is removed out, and then it is after the getting of UO3, this is leaching. Leaching will be takes place. So what happened first method, when the pitchblende is taken, that is crushed into fine powder and making into magnetic separation. Some magnetic ore will be keeping one side and another impurities will be separated. And during of the fourth reaction, by because any sulfur content will be there, that will also removed by means of the froth partition method. Next roasting method, here some of the compounds we are what the roasting means. But here in this case, in presence of oxygen, we are roasted. Formation of the carbon dioxide, sulfur dioxide removed, and arsenic, antimony also. These are the volatile impurities which are present in the pitch blende that are also removed, and then the obtained compound will be leaching. Leaching means what? It is treated with the acid. So the roasted ore is leached with the concentrated sulfuric acid. The oxide is dissolved in the acid to give the uranyl sulfide. So what happened from this UO3? You are treated with the sulfuric acid. The uranium trioxide will be treated with the sulfuric acid. We are getting off uranyl sulfide, UO2SO4 plus water molecule will be removed out. This is called as a leaching. Leaching means treated with the acid. Next, uranyl sulfide will be. Then the fourth process is we are extraction of the urine. It is treated with the sodium carbonate. That means the uranyl sulfide is treated with the sodium carbonate. Whatever the impurities which are present, like iron, copper, magnesium, which are precipitated out. So we are getting off this particular treated with the uranyl sulfates. Sodium carbonates. You are getting of the sodium uranyl carbonate will be formation. Sodium uranyl carbonate. That means you are having now. Okay, this will be formed. Sodium uranyl carbonate, a complex compound is formed. This is a complex compound. During this one, so many other impurities like the copper, iron, magnesium, which are precipitated out. Copper, iron, magnesium impurities will be precipitated out as a PPT. It's a byproduct which is obtained by the help of the sodium carbonate base. Okay, this sodium carbonate complex compound treated with the sodium hydroxide, strong base. Whatever the obtained uranyls after getting of the complex compound, the complex compound is treated with the sodium hydroxide, so that you are getting of sodium diuranate, a precipitate is obtained. So fifth method is the complex compound is treated with the Na4UO2 treated with the sodium hydroxide. Strong base is treated. You are getting of sodium diuranate. You are getting of sodium Na2U2O7. Sodium diuranate is obtained, and remaining byproduct sodium carbonate is removed out as a base, and also water molecule will be removed out. Okay. So sodium diuranate is removed. This sodium diuranate is dissolved in the next sixth process. It is dissolved in the HCl, formed uranyl chloride. Later, it will be treated with the ammonium hydroxide, and also added ammonium diuranate is precipitated out. So, the obtained sodium diuranate is treated with the HCl, and later it will be treated with ammonium hydroxide, so that you are getting of ammonium diuranate is precipitated out. This ammonium diuranate is separated by heating of 700 degrees Celsius. You are getting of U3OH. Ammonium diuranate will be formed when you are treated with this one. That means sodium diuranate is treated with the HCl, and also treated with the ammonium hydroxide. This is ammonium hydroxide. We are getting of ammonium diuranate is formed. Getting of ammonium diuranate, which is formed. This ammonium diuranate is on strong heating, which is strong heating. Then it is strong heating. You are getting of pitch blend, that is uranyl, that is a pitch blend. The pure pitch blend is obtained. Ammonia gas will be removed out. That is ammonia gas is removed. Okay. So pitch blend. These are the steps which are having of it. It's the lengthiest process. So many technical uses are using. First is the concentration of the ore. Next is the roasting. Next is the leaching. Next is the base, that is sodium, a complex compound is owned. This complex compound is treated with a strong base. We are getting a disodium uranate. Disodium uranate is dissolved in the HCl and treated with ammonium hydroxide. You are getting off that one. That on strong heating, you are getting off U3OH is a pitch blend is obtained. Okay. So many number of steps are involved in the preparation of extraction of the uranium. Now this particularly extraction of the uranium from the U3OH, whatever that one, it is treated with the carbon. That means in the furnace, the seventh step, pitch blend. It is a pure pitch blend is treated with the coke carbon. It is heated. That particularly heated in electrical or for arc furnace. So you are getting off uranium, and also carbon dioxide is removed out. Okay. So friends, here 3 moles of that's one, and carbon dioxide means 4 moles of carbon. Pure uranium is obtained by means of the 7-8 steps. You are getting of the uranium metal will be extracted. Okay. So only simple the thing is we have to remember is first is concentration of the ore by means of magnetic separation and phosphorylation. Then roasting, that will be oxide is formed. Then it is leached, uranium sulfide is formed. Then it is treated with the sodium carbonate. So sodium uranyl, that is a complex compound is formed. That complex compound is treated with the base. Disodium uranate is formed. That sodium disodium uranide, that sodium uranide is treated with the acid. That means it is dissolved in the HCl and treated with the ammonium hydroxide. That formed ammonium uranate is strong heating. You are getting out the pitch blend. This pitch blend is carried out in the electric arc furnace, treated with the carbon, coke, pure carbon, so that we are getting off uranium and carbon dioxide is removed out. Okay, this is the process of the extraction of the uranium. So next is this. What are the uses of uranium? You know that this particularly main uranium is used in the nuclear reactor to getting off nuclear energy purpose. Mainly, particularly this uranium, and also it is used in the this uranium is used in the glass and ceramic industry for the color coating purpose, coloring agent. Sometimes this uranium also act as a catalyst in the synthesis of ammonia also. Mainly, it is used in the process of nuclear energy purpose. Why? Because it's the most costliest one. You can't use in the ceramic, and that means is a, even though it is a coloring agent, but it is a radioactive element, and it is when you are using the catalyst in the synthesis of amino, it is also very dangerous. Why? Because uranium is a radioactive element. Okay, so this is about the extraction of the uranium. Okay, so it is also very important in your examination point of view. You have to be aware of this particularly, how to getting of the uranium. Only the thing is main important is the minerals. We are having of the three minerals are there: pitch blende, and also ornithite and atonite. That you have to remember the formulas, and the extraction is 7-8 steps are there: concentration, roasting, leaching, and treated with the sodium carbonate, treated with the complex is treated with the base sodium hydroxide, and it is dissolved in the HCl, then treated with the ammonium hydroxide, then that particularly treated up to 700 degrees Celsius. The obtained pitch blende is undergoes in the electric arc furnace with the help of the coke. We are getting off uranium. Okay, these are the methods which are present in the extraction of the uranium. Now we go to the last extraction of thorium. So it is not removed from this one. Okay, so friends, we'll go to the test. I will explain. Tomorrow I will write on the blackboard, because it is even though not a permanent marker, but this load whiteboard is not that much of easy to remove this one. And third is extraction of the thorium. So what are the important minerals of the thorium? Thorium is having of the important minerals of monazite, thorite, uranothorite. Again, three are there important minerals of the thorium. Important minerals of the thorium is we are having of the monazite, which is very important one. From the monazite only you can extract this one. Okay, so that is 18% of thorium. The sand, which is consisting of as a silicates. Totally silicates, that means sand is present. Okay, second is we are having of thorites. We are having of this is thorium, and third is uranothorite, which is present in that one mineral chloride is thorium oxide, uranium oxide, and silica, N times, and water molecule will be present. This is mineral chloride. Okay. In that main important is the monazite is a very important one. Monazite, from the monazite you have to extract the uranium. Okay. So just I explain that one. In this extraction of the uranium, that is thorium, by means of monazite mineral. The monazite mineral will be out to that one. The first method, see the extraction, that will be having of the extraction method. First is the concentration of the ore. The steps whatever you are followed in the uranium, same steps you are following. Concentration of ore. That is monazite sand is contains of 2 to 6% of monazite. Then it is concentrated with the 90%. That means concentrated means 60% of monazite will be converted into 90% of monazite. Simply by means of magnetic separation, by means of phosphorylation, we are getting of this particularly. So first is converted into washing and magnetic separation. Here you are taking washing will be takes place and magnetic separation. Two methods which are used in the concentration of the extraction of the thorium from the monazite, from this monazite. Okay. Next is leaching. Next, monazite is heated in the presence of concentrated sulfuric acid. Second method is leaching. So here monazite is heated with the monazite means thoria is heated with the sulfuric acid. We are getting of thorium sulfate and water molecule will be removed out. Okay, this is the thorium. That means leaching will be. In this conversion of thoria is metallic thorium. It is to get from the leaching, that is it is very difficult to get the metallic thorium, but require high temperature due to the reduction takes place. So that this method is a very getting off this one. So next will thorium sulfate. After that thorium will be getting of the thorium is very difficult. So that you are having of the number of methods you are using. The thorium oxide will be treated with the cobalt chloride. We are getting of thorium tetrachloride, one method. Thorium tetrachloride is treated with the sodium. We are getting of thoria. Or one more method is thorium oxide and reduction with the calcium. We are getting of thorium. Another method is thermal decomposition of tetrahydrothoriate. That will be there. Three methods in any one method you can extract it. But the last, that is the third method is extraction of the thorium. By steps are any one method you are using of. One method is when thoria, that means monazite is treated with the cobalt chloride, that will be we are getting of thorium tetrachloride. This thorium tetrachloride and carbon dioxide will be removed out. Okay, this thorium tetrachloride is treated with the sodium metal. You can get the thorium and sodium chloride. This is the food. Another method is second method is when the thorium, the thoria, that is monazite sand is treated with the calcium. Thorium is obtained and calcium oxide is that is removed out. This is the one more method. And one more method is why? Because from this leaching, after the leaching, getting of the thoria is very difficult. So depending on the conditions, we can apply in the which compounds, whether you are treated with the carbonyl chloride or calcium, or you can use a directly decomposition of tetrahydrothoriate. Tetrahydrothoriate decomposition. This will be treated out at about the 700 degrees Celsius. You are getting of thorium and also iodine will be replaced. This is the method. Any one method from that you can extracting of this particularly this thorium is prepared out. Okay. So this is about the thorium extraction of that one. And properties of the thorium: pure metallic thoria is soft and it is melts about the 89. The melting point is very high Due to of this one melting point, this particularly it is very important thorium. It is a malleable and ductile in nature. Compared to the remaining other elements, it is very easy, malleable one and ductile one. So where it is used? It is used in the production of the enriched uranium. Very important. This thorium is used for the extraction of the uranium-235. That is called as enriched uranium. You know that in our Hyderabad we are having of NFC, nuclear fuel complex. In the nuclear fuel complex NFC in the Nacharam, that is there, they have prepared the enriched uranium with the help of the thorium only. Okay, with the help of the thorium, you can prepare the enriched uranium, uranium-235, which is used as a nuclear energy purpose. Okay, and it is also used as a thorium is used as a alloys, preparation of the alloys. The two uses are there. Main important uses is thorium is used for the preparation of enriched uranium. Enriched uranium means uranium-92-235 isotope of the uranium. Actually, uranium-92-237 is there. Uranium-92-238 also there. Uranium-92-235 is called as a enriched uranium, which is used in the nuclear reactors. In the nuclear reactors, you can use for the purpose of generation of the electricity purpose, or you can prepare the bombs also, atom bombs, that is prepared in the nuclear reactions. Okay, this is about the our extraction of the thorium. Okay, so we'll go to the next block, that is the second block, organic block. In that organic block, we are having of why, because the board is not that much of comfortness. Tomorrow I will explain that is next organ, that is particularly I will write on that one. Here organic block means here consisting of the 3 chapters are there: heterocyclic compounds, okay, and hormone, that is nucleic acids, amino acids, proteins and vitamins. These are the 3 chapters, very important 3 chapters. First we have to go to the heterocyclic compounds. The first one, heterocyclic compounds. So what are the heterocyclic compounds? See, heterocyclic compounds are the 5-membered rings are there. That means apart from the carbon and hydrogen, heterocyclic compounds are those cyclic compounds which contain, besides of the carbon and hydrogen, one or more heteroatoms such as nitrogen, oxygen or sulfur, which are present. Those are called as heterocyclic compounds. They are heterocyclic compounds are here. That is, we are having of that one heterocyclic compounds. Heteroatoms, 5-membered rings are there, and also 6-membered rings are there. 5-membered rings means consisting of. I will stop this video. So only the art. Why? Because the board is not completely, that is erasing. So due to that reason, just I am explaining the what are the heterocyclic compounds, what are the uses of that one. So here heterocyclic compounds are mainly 5-membered heterocyclic compounds are there, 6-membered heterocyclic compounds are there. So heterocyclic means apart from the carbon and hydrogen, we are having of the elements are oxygen or nitrogen or sulfur, which element which are present in the cyclic compound. Those are called as heterocyclic compound. The 5-membered rings of heterocyclic compound, very important, are you are having of furan, pyrrole, thiophene. Furan means consisting of, you are having of the oxygen. Pyrrole means consisting of the other element, heteroatom is nitrogen. Thiophene is consisting of sulfur is the heteroatom. Okay, so these are the 5-membered heterocyclic compounds: furan, pyrrole, thiophene. It goes to the 6-membered heterocyclic compound, means pyridine is the very important one. That means 6-membered heterocyclic compound is pyridine. The heteroatom is nitrogen is present. Okay, so where these heterocyclic compounds are used in our daily life means, which is a very important, heterocyclic compounds are widely distributed in the nature in the form of vitamins, In the vitamins, heteroatom, that means heterocyclic compounds are there. In the amino acids also, heterocyclic compounds are there. In the proteins, in the enzymes, antibiotics, and also plant pigments. Plant pigment means plant pigments such as the chlorophyll, heterocyclic compounds are present. Not only that one, genetical compounds. Genetical compounds means RNA and DNA. Means ribonucleic acid and deoxyribonucleic acid. In that also heterocyclic compounds are present. So very important of the heterocyclic compound which are present. Okay, 5-membered or 6-membered. So 5 members are 3 are there, only 3 we are learning in this 5th sem. That is pyrrole, furan, thiophene. And 6-membered means pyridine is there. That also not in your syllabus. Only 5-membered rings are you are considered in the your 5th sem syllabus point of view. So 5-membered ring means furan, pyrrole, thiophene. How to preparation of heterocyclic compound? That is important. The preparation will be for the 3 5-membered rings like furan, pyrrole, thiophene, which is extracted or prepared by means of Pallnar synthesis. One is the important synthesis is there, that is the Pallnar synthesis. By means of Pallnar synthesis, what are the raw material you are using in the Pallnar synthesis? Means 1,4-dicarboxylic compound. 1,4-dicarboxylic compound is treated with a different reagent. You are getting of different 5-membered heteroatoms. Suppose I want the furan. So the 1,4-dicarboxylic compound is treated with the phosphorus pentoxide P2O5. You will getting of furan. If 1,4-dicarboxylic compound is treated with the ammonia, you are getting of pyrrole. If 1,4-dicarboxylic compound is treated with the phosphorus pentasulfide P2S5, we will getting of thiophene. Very easiest synthesis to write in the examination, that is a Pallnar synthesis. For the 3 compounds you can prepare. Only the thing is reagents are different here. You are using the reagents are different only. Remaining all the things are same. That means the raw material, the starting material is 1,4-dicarboxylic compound. 1,4-dicarboxylic compound is treated with the phosphorus pentoxide P2O5. You are getting of pyrrole. That is furan. You are getting of phosphorus pentoxide. You are getting of the furan. When 1,4-dicarboxylic compound is treated with the ammonia, you are getting of pyrrole. Okay. When 1,4-dicarboxylic compound is treated with a phosphorus pentasulfide P2S5, you are getting of thiophene. That's it. This is the main important preparation of the 3 heterocyclic compound with the help of Pallnar synthesis. Next, second preparation of the furan or pyrrole or thiophene. The second is in the furan preparation, furic acid. That means in the furan, at the first position, carboxylic acid is there. That is called as a furic acid. The furic acid decarboxylation. Decarboxylation means removing of the carbon dioxide. You will getting of furan. Simple. Next, preparation of the pyrrole. That means only when ethylene gas and ammonia gas. Ethylene and ammonia gas is passed through the red hot tube. Ethylene gas and ammonia gas is passed through the red hot tube. You are getting of the pyrrole. Simple. And thiophene means a mixture of ethylene gas and hydrogen sulfide. In the second pyrrole method, we are using ethylene and ammonia. Here, ethylene and hydrogen sulfide H2S gas pass to they are passing to the heated aluminium. Alumina is again one more reagent we are using of. These 2 gases are passed to the heated alumina. You are getting of thiophene. This is also very important preparation of the heterocyclic compounds. So first is the Pallnar synthesis. Pallnar synthesis is 1,4-dicarboxylic compound. 1,4-dicarboxylic compound which are used for the preparation of heterocyclic 5-membered heterocyclic compound. When 1,4-dicarboxylic acid is treated with the phosphorus pentoxide, you are getting of furan. Second is when 1,4-dicarboxylic acid is treated with the ammonia, you are getting of pyrrole. Third is When 1,4-dicarboxyl compound is treated with the phosphorus pentasulfide, you are getting of thiophene. So every one heterocyclic compound is prepared by means of Paul-Nassini. Second method of preparation of furan is puric acid is on decarboxylation. Puric acid is decarboxylation, means strong heated. Carbon dioxide is removed, furan is formed. And pyrrole means when ethylene gas and ammonia gas, which are passed to the red hot tube, very red hot tube, you are getting of pyrrole. And thiophene is prepared when ethylene gas and ethylene gas and hydrogen sulfide gas has passed through the red hot alumina. Alumina is heated. So heated alumina, you are passing the ethylene gas as well as the hydrogen sulfide gas. You are getting of thiophene. This is the second method of all three heterocyclic compounds are prepared. Now the third method. Why? Because this is a 10 marks question, preparation of heterocyclic compound. At least you have to write each three types. That means different types of preparation. Next, furfural. Before that, you are using the furic acid. That means acid is used. Furfural means aldehyde. And the furan, we are having on the first position, aldehyde CHO group is there. When furfural is decarboxylation, again the decarboxylation, carbon monoxide is removed out. We are getting of furan. Okay. Next, pyrrole. This is the main important, commercially prepared by means of this method. Mixture of furan and ammonia. Mixture of furan. That is whatever you prepared just now, furan and ammonia gas is passed through the heated alumina. That means alumina is a reagent which are is furan and ammonia are passed through the red hot alumina. You are getting of pyrrole. Okay. Next, commercially, thiophene is also prepared by means of vapors of N-butane and sulfur. Butane, N-butane and sulfur, that vapors, that means in the gaseous state of the N-butane and sulfur is passed at about the 600 degrees Celsius. Thiophene is prepared. These two are the preparation will be commercial methods of the preparation. These two are the commercial methods which are prepared the heterocyclic compounds. So these are the important preparation in the examination compulsory question, the preparation of the heterocyclic compounds. Very simple, just practice it. We are having only three methods are there. First is the Paul-Nassini method. By that you can prepare all. Next is the decarboxylation, or we are passing the red hot tube or passing to the alumina. Next, third method is commercial method. That is the mainly furfural is treated with the ammonia. There is a decarboxylation. You are getting a furan, or furan ammonia gas is passed to the alumina. You are getting of the pyrrole, or vapors of the N-butane and sulfur. Vapors of the N-butane and sulfur is passed to the, that is treated with about the 600 degrees Celsius. You are getting of the thiophene. Okay, this is about the preparation of the heterocyclic compounds. So next is the resonance structures. What are the structure of the heterocyclic compounds? 5-membered rings. How they are resonance takes place? What are the steps which are, how many resonance structures will be present? Okay, so in the, we are having of the double bonds or two bonds are present. So delocalized double bonds which is carrying of that one, so that we are getting of the remaining other compound. That is the resonance structures will be formed. Just mobility of the pi electrons. Why? Because the pi electrons are delocalized one. Here anywhere the pi electrons are present, the delocalized takes place, so that pyrrole, furan, thiophene, we are getting of that. But thiophene is having of one extra resonance structure because of the thiophene. In the thiophene, sulfur is undergoing of, that sulfur will be in the d orbital. The sulfur present in the 3d orbital, hence it is having of the extra resonance structures instead of 4. Okay, 5 resonance structures are there, but here thiophene is having of the 6 resonance structures which are possible of that one. Here also the thiophene is having of the sulfur, not only the sulfur is less electronegativity than the oxygen and nitrogen. Hence, resonance structure of the possible of thiophene ferrol is not in the same structures. Okay, the more resonance structures are possible for the thiophene. And also it is thiophene also large amount of resonance energy is there, that is 30 kilocalories of resonance of the thiophene is there, but furan ferrol is having of only 20 kilocalories per mole of the resonance energy is there. Because of this also one resonance structures of the thiophene is having of extra. Okay, so this is also very important reason why, because it is asking for the what are the resonance structures of the furan or ferrol or thiophene, they asked in the examination point of view. Okay, so due to the high resonance structures of the thiophene, the resonance energy also high, it is 30 kilocalories per mole. Furan and ferrol is having only 20 kilocalories per mole is there. Okay, so this is about the resonance structures of the thiophene. Now coming to the orbital picture also there. That is orbital picture also. They asked the orbital picture of the ferrol, furan, and thiophene. How the delocalized pi electrons will be getting of the orbital picture. How they are forming in the orbitalized, that means upper layer, lower layer. That means in between the a sigma complex is formed. The pi complex also, pi electron cloud is there. Above and below layers which is having of the sp2 hybrid orbitals present, that will be showing on the furan, ferrol and thiophene orbital pictures. Next is the chemical compounds. What are the chemical properties of the ferrol, furan and thiophene which are using of? Here every topic is very important. Okay, preparation of the heterocyclic compounds, resonance structures of the heterocyclic 5-membered heterocyclic compounds, and also orbital picture of the heterocyclic compounds. Next, chemical properties of the heterocyclic compounds of furan, ferrol, thiophene. That also you have to learn. So the chemical properties of the 5-membered heterocyclic compounds which are undergoing of electrophilic substitution reactions. How the electrophilic substitution reactions, just now we are already resonance structures we are taken as this resonance structures of electrophile will be attacked on the second position. Simultaneously we can attack on the third position, but second position is more stable. The electrophilic substitution reaction in the heterocyclic compound, second position is more stable than the third position. Why? Because at the second position we are getting of 3 resonance structures compared to the third position. Third position, if you are attacking the electrophile, we are getting of 2 resonance structures only. 2 resonance structures only. But in the any heterocyclic compound, at second position, you are getting of the three types of, that means 3 resonance structures are possible for the that one. These electrophilic substitution reactions, 5-membered heterocyclic compounds are more reactive than the benzene. This electrophilic substitution is more reactive than the benzene because this having of the sulfur 5 electrons are there. The 5, the particularly thiophene. So sulfur is having of the 5 electrons. The sulfur, the order of reactivity, ferrol is more than the furan, and furan is more than the thiophene. Thiophene than the benzene. That means reactivity will be more in the ferrol. Next is the furan. Next is the thiophene. The last is the benzene. That will be undergoing of electrophilic substitution reaction. Maybe Friedel-Crafts acylation, maybe Gattermann reaction, maybe coupling reaction, maybe Raymond-Ramer reaction. All this will be takes place in the ferrol. Gattermann reaction means SCN and SCN. When the ferrol is treated with the HCN, hydrogen cyanide, and in presence of hydrochloric acid, you are getting of 2-formyl. That means formyl ferrol. That means at the second position, aldehyde group is attacked on that one because of the Gattermann space that will be there. If the Friedel-Crafts acylation means we are getting of acetic anhydride. When acetic anhydride is treated with the ferrol, the second position will be attacked and the 2-acetyl ferrol will be formed. When you're taking of the Raymond-Ramer reaction, that means in presence of chloroform and base, the ferrol is reacted with, you are getting of 2-formyl ferrol is formed. 2-formyl ferrol. That means Formal group means aldehyde group is attacked at the second position. At the second position, formal group is attacked. You are getting of the 2-formyl ferrol is formed. That is about the ferrol chemical properties. Like that, furan also undergoing the same Friedel-Crafts acylation, Getterman reaction, coupling reaction, and also Friedel-Crafts benzylation will be takes place. That will be taking place of the 3 common steps. Thiophene is having of the Friedel-Crafts benzylation. That means 2 benzyl thiophene is formed. Okay, so this is about the our chemical properties of the furan, ferrol, and thiophene. This is about the heterocyclic compound. That means the unit of 4th unit. So very important that unit in the examination point of view. This will be again one more. That means I will be brushing about this one heterocyclic compound. 5-membered heterocyclic compound is there. 6 members are. 5 members are furan, ferrol, thiophene. Okay, 6-membered is pyridine. Preparation of heterocyclic compound. 5-membered heterocyclic compounds. First method is polymer synthesis. Here the starting material is 1,4-dicarboxylic compound. 1,4-dicarboxylic compound is a common material for the synthesis of 3 heterocyclic compounds. Only the reagent will be changes. When 1,4-dicarboxylic compound is treated with the phosphorus pentoxide, you are getting of furan. When 1,4-dicarboxylic compound is treated with the ammonium, you are getting the ferrol. When 1,4-dicarboxylic compound is treated with the phosphorus pentasulfide, you are getting the thiophene. That's it. Next is we are having of the sulfuric, that is fural. When you are treated with the fural also, that also taking out of that compound that will be prepared out. Commercial method is there, and also when the general method of acetylene and ammonia gas is passed through the red hot tube, that also ferrol is formed. Okay, thiophene means N-butane and also hydrogen sulfide, which is passed to the red hot alumina. You are getting of thiophene. That is the important of the preparations of that heterocyclic compound. Next is resonance structures. How the pi bonds will be delocalized, how the changes will be takes place. That is, we are getting of the resonance. 4 resonance structures will be possible for the furan and ferrol, but thiophene is having a 1 more extra resonance structure because of sulfur atom is present. The sulfur atom is present in the 3d orbital. Due to that reason only, we are getting of more resonance structure. If any compound is having of more resonance structure is which is the more stable than the other compounds. So when you are comparing with that one ferrol and furan, thiophene is a more resonance structures. That's why it is having of the high resonance energy. 30 kilocalories per mole of resonance energy is there for the thiophene. But remaining whatever the furan and ferrol is only 20 kilocalories per mole of the resonance energy will be there. Okay. Next is they are having of the orbital pictures. Orbital means the pi cloud will be formed above and below the plane. The orbital picture will be getting of the orbital picture. Next is the chemical properties. Chemical properties are there. Why? Because due to the resonance structure, they are undergoing of electrophilic substitution reaction. The electrophilic substitution reactions also there is we are having of the 2 positions are there. At second position or third position, both are same. At second or fourth are same. Third and fifth are same. That is the important one. Okay, so we are getting of the second position, third position, which are possible of the electrophile will be attacked, but at second position more stable form compounds will be obtained because of 3 resonance structures are present at the second position. At third position, only 2 resonance structures are possible. That's why at the third position is less stable compounds are there. The electrophile will be attacked, and the second position is very important. So that in the furan, ferrol, thiophene will be giving up the chemical reaction with the Friedel-Crafts acylation, Getterman reaction, and also your Riemann-Tamer reaction. These are the possibility of getting of that one. This means acetyl chloride, acetic anhydride. Suppose when furan is treated with acetic anhydride, you are getting of 2-acetyl furan will be formed. Okay, if Getterman reaction, hydrogen cyanide in presence of HCl, we are getting of the furyl. That means aldehyde group is formed. Even though Riemann-Tamer reaction, that means chloroform in presence of the base. So chloroform means we are getting of this particularly at the second position. Aldehyde group is attacked. 2-furyl furan or 2-furyl ferrol. But in the case of thiophene, we are having of the benzyl chloride. Instead of acetyl chloride, benzyl chloride is treated. 2-benzyl thiophene will be formed. That is about the heterocyclic compounds which are present in the chemical reactions. Okay, so main important of uses of heterocyclic means the various fields. That means in the vitamins, in the amino acids, in the proteins, in the enzymes, in the photosynthesis, that like you are having of the chlorophyll also that will be present, and our endocrine glands, that means ribosome, the DNA and RNA also heterocyclic compounds are there. So a wide range of heterocyclic compounds are useful in our daily life. That's why the heterocyclic compounds are very useful. That will be taken place. Next lesson we are having of the amino acids. The amino acids we are having of next amino acids, proteins, and vitamins, enzymes that will be there. Those are also very important. What are the amino acids? We know that one. Our body is consisting of 25 amino acids are there, maybe 26, just like alphabets. So alphabets, 26 alphabets, like they are amino acids are 26 amino acids are there. In that 26 amino acids, our body, it can own self prepared 15 amino acids. Remaining 9 amino acids or 9 or 10 amino acids which are prepared the body by means of the only diet only, through diet. Those amino acids are called as essential amino acids. So friend, amino acids are also very important. Preparation and chemical properties are there. So the important of amino acids, you can learn what are the important. Why? Because without amino acids, our building blocks of our body is amino acids only. When you are taken anything food, it will be converted into proteins. The proteins are hydrolyzed, you are getting of amino acids. Then amino acids are hydrolyzed, you are getting of DNA or RNA. That means nucleic acids are formed. So this is a process which are involved in the our body system. Okay, when you are taking the diet means the diet is digested, it is converted into protein. The proteins are converted into amino acids. Amino acids are converted into nucleic acids. This is a system which are following. Then only you are fit for health. Otherwise, any things are not there. That means this is everything is present in that our body means through the diet only. Only few amino acids are prepared our body itself. 15 are there. But remaining other amino acids, 9 or 10, that is the 10 amino acids that will be prepared our body with the help of the food only. So you must take the protein food, that is rich amount of the protein food. Then only the 6, that is a 9 or 10 amino acids were prepared by the body. Then only our organs will be sustained perfectly. Otherwise, that is a problem will be arises. Those amino acids are called as essential amino acids. The essential amino acids are very, very important to the body. That will be obtained from the diet only. Okay. So friends, we'll discuss that amino acids in the next class, amino acids and proteins, and also vitamins and enzymes. That will be there in the next class. We will discuss that one. Okay, friends. So I'm leaving today. So